Alright, so I've decided the best way to spend my evening is calculating the properties of cum as a rocket propellant. I'm going to assume it's being used in a nuclear thermal rocket here, since they accept a wider range of propellants and don't require finding a way to make it combust as in a chemical rocket. You could ostensibly make a cum-fueled chemical rocket if you were willing to separate the water and semen into hydrogen and oxygen and distribute the other compounds present between the two, before then proceeding to use them in a fairly conventional hydrogen-oxygen chemical rocket. But I'd prefer to keep the semen intact here for the sake of purity. So, with that being said, my current understanding is that if you ran the reactor at about 3,200 degrees Kelvin, you would get an exhaust velocity of about 4 kilometers per s. We need not concern ourselves with the difficult, if not outright impossible, process of making the semen combust, as a nuclear thermal rocket operates on the fairly simple principle of energizing mass via heating it up using nuclear fission and throwing it out the back to produce thrust based on Newton's third law, or F equals sign ma. Thus, it should be possible to use it as propellant in this scenario. One of the main advantages of NTRs is that they are about twice as efficient as conventional chemical rockets. Using semen here gives us an exhaust velocity half that produced by conventional hydrogen propellant, and thus brings us back down to performance in terms of efficiency akin to conventional chemical rockets, such as the main engines on the Space Shuttle or SLS. This entirely negates NTR's advantage over these rockets, but still gives us a fairly effective rocket capable of being ran entirely on semen. Additionally, semen has a density over 16 times that of hydrogen. This enables us to store it much more easily than this conventionally used propellant, although admittedly this is an advantage already offered by other non-seminal propellant types. However, to fully preserve the sperm and thus maintain the purity of the propellant, it is required that we freeze it in a manner akin to the active cooling that would have already been present for storing hydrogen propellant in a liquid state. We can assume that it would be thawed out and converted back into a liquid state shortly before any major engine burn. The other issue we have here, though, is that the water and salt in semen would slowly corrode the reactor core, or more specifically, the outer surfaces of fuel rods exposed to the propellant as it passes through the core. This would, over time with usage, cause radioactive nuclear fuel in the form of low-enriched uranium to contaminate the exhaust. Therefore, using this propellant type would, with usage, cause you to produce a superheated, hypersonic jet of radioactive cum traveling at 4 kilometers per s, or Mach 11. So, to summarize all of this in terms of pros and cons, would be difficult to obtain enough semen to power a rocket. Possible solutions include posting an Elon Musk tweet to r/SpaceX or similar subreddits. Completely negates the advantage nuclear thermal rockets have in terms of ISP over conventional chemical rockets due to the inefficiency of cum as a propellant. Would slowly corrode the reactor core, causing bits of radioactive material to leak into the propellant, thus making the superheated cum jet radioactive. Requires active cooling, such as with a liquid nitrogen radiator system, to preserve the sperm over long periods of time. Whilst easier to store in terms of volume needed than conventional hydrogen propellant due to higher density, it offers no advantages here over non-seminal propellant types. Pros: nuclear cum rocket.